Then another bit about Kotlin that you may have seen, and that is quite an interesting aspect of what you can do with the language, is something called domain-specific languages. So what is a domain-specific language? In principle, a domain-specific language is a language that is written to solve a problem in a specific, often quite narrow, domain. What does that mean? That means that in that domain, we want to, so for that language, we want to talk about concepts in the domain and make it look natural for that domain so that it becomes very easy to write those things. And Kotlin has sufficient language structures that you can actually make something with your library that makes it look like you have such a language. Of course, it is still Kotlin. It's valid Kotlin. So we want to be able to express things in a domain-specific way. So basically what you can do is to actually interact with, make things look like another language, to express your ideas very clearly. So, but without, so the other ways that people use these things is they use kind of code generation or something like that. So you use multiple languages in the same project to be able to use a language to specify a domain concept. Or you actually use just strings and you embed those in your code. Where do you use it? For example, if you use SQL in many languages. Or HTML when you generate HTML. But what the disadvantage of that is that you don't have any type safety, you don't have any completion. You might need to do code generation as well. So before we look at the elements of domain-specific languages that make it work, let's have a look at these enablers. So what are the parts of Kotlin that make that work? So particularly what makes it work is the inline functions with lambda parameters, extension functions, infix functions and operator overloading, and there's something called a DSL marker. Another one that actually makes it work quite well is the ability to use to have property delegates, and in particular the overloaded functions to create property delegates make things a lot tidier. So what kind of DSLs can you find? What does it look like? One of the examples is the Kotlin DSL for Gradle. You have been using Gradle. Let's look at it full screen. So when we look at this, it almost looks like it's Gradle in Groovy, which is another programming language that has these capabilities of being quite tidy. But Groovy is a dynamic language, so it doesn't have all this type checking, etc. that Kotlin does. But what you can do, and the Kotlin DSL for Gradle does take a little hack. What it does, it first runs the plugin block, and then it uses what it gets from the plugin block to provide code for the rest. And using that, you have available various concepts that are created by your plugins, basically. So there's 3 plugins here. In this case, in this project, I have my own plugin basically to make it easier to use multi-platform projects. And I don't need to put the code in every file because this is the entire build file. So we still have a description. We have our API. It's Kotlin, so we need to use parentheses rather where in Groovy this is not required. We have our source compatibility, target compatibility, etc. So there's a little bit of differences, but it still looks like our Gradle file, where we have the ability to declare our dependencies. Yes, it happens that these dependency blocks get executed, and then these are function calls that actually result in updating some configuration objects, but we don't need to care. It looks really, really natural. And with this configuration, we can then use that to build our code. Another one is the Kotlin HTML library. So this is a multi-platform library. You can use this in JavaScript as well as in in Java, and it allows you to create HTML, to generate HTML in a type-safe way. So in particular, what we see here is an example where I have some function that, so this was something that, so it does a little bit of hacking because it provides this context tag consumer is a tag consumer that I added, that I have created, that also has some sort of context, because I want to be able to actually use a context for many things. So in this case, what you do here is you basically can create HTML elements. So we need to create a div, and we want to set these are the classes. It's the class property, etc. So you can set properties, you can call child. So the plus here is used to actually add text content. So yes, you cannot get HTML 100%, but you can get something that's really, really tight. I've also played around with this myself for a project I use, and basically this is a DSL for SQL access, because writing SQL can be a bit tedious. Another aspect of, if you do it in SQL itself, then your language, your system has no concept of what the database should look like. What I'd like the ability is that you point me to a database, and I will just initialize, create the tables myself, or update the tables if and when needed, without specifying anything double. If preferably I don't want to specify how to go from one version to the table to another one. So this is a DSL I created for creating a database. So you can have multiple users, and what you do is, so this is a database, and inside the database there's a number of tables. In this case, we have so extraconf allows you to pass some extra information to, in this case, MySQL, that says, okay, this is the character set to use and stuff like that. So what we have here is val user by varchar, and then varchar is configured with these. These are properties that when you call them, they will actually update the setting. So these are, the getter is actually mutating state. This is not necessarily very clean in a normal way, but in this case it makes for a very tidy way of using it without needing to use parentheses. I could use parentheses, but why? So what does this mean? Well, it creates a varchar column named user with 30. An interesting aspect of this is actually, because of the overloading, we could actually leave out user here, and it would still be able to know what the name of the property is. And it is actually implemented that works, but I didn't give you an example where I used this. But if you leave, so there's another overload of varchar that doesn't take the name, that will do this correctly. So this is a table definition, and it looks very much like your regular SQL would look, your database definition things. And when you use this, it looks something like this. So this is a function where we create an authentication token for an account manager. So we generate our token, which happens to be just some random number. It doesn't really matter. And then we can say, okay, we have a database connection and we want to update something in there. So we call this update function, and inside there we can actually, the connection knows what the database type is. So we call insert there. We use the capital letters because that fits with what SQL does normally. We could use lower letters, but I thought it would be nice. And this tries to stay very close to how SQL works, but there is a major difference. These column references that come from our previous table, so these users, this users object has these properties that are columns. So we can use those columns here. So T is basically a shortcut for this particular table. And user gets that column, and what it does, it will actually have all kind of type information associated with it. So it knows that seconds is a number, that username is a text field. So most of the things here are varchar. So time is a date. So it will work that correctly. And then of course it needs to call commit, and then there's some error checking. So this is how you can use this in a way, and let it be type safe.